I'm here today to talk about rules. And I don't know, okay, I have a hard time even saying this out loud, but I'm going to ask, how many of you are familiar with the Sandi Metz rules? Okay, that's just creepy. Like, imagine you're me. So I have been avoiding talking about the rules for a long time because of the kind of being slightly wigged out factor. But I want to give you some, but I finally gave in and started talking about them. And it's for a couple of reasons. The story behind the rules is I was in San Francisco a year ago in December working at a place. And they were like all people who call me up and ask me to come and look at their code, right? People do not call me when things are going well. This is not what happens. I don't go in and say, wow, you don't need me, nothing need be done. Write me a check and I'll leave, right? That is not what happens. What happens is they do this. They say, you know that Gary Larson cartoon where he's talking to what you say and what your dog hears? So put me in the role of Ginger, the dog. They open up a whole bunch of screens and they say, wow, 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 and they say, what do you think we should do about that? That's what happens to me, right? And so, and these are in 5,000 line active record models and mini, right? This is the kind of deal, this is welcome to my world. And so I spent a week there with these guys, and at the end they wanted me to give them some rules for writing code. Now it's a real challenge, right? What do you give people? Like you would like rules to be simple and straightforward and quick and easy to remember. Like you want them to be things they can apply. And so if someone asks you, give me a set of rules that's short enough so that I can remember, what do you tell them about code? And so I made up on the spot a set of rules that I made as an antidote for the 5,000 line active record model, right? I wanted to push, they had a teeter-totter that looked like this, and I wanted to put a lot of weight on the far end of the other side of the teeter-totter. And these are the rules I gave them. I said, 3 of the rules are about writing general object-oriented code, and 2 are about Rails. Actually, I'm not going to go there yet. So I gave them some rules. I'll just tell you, rules are coming. I gave them some rules, and then I kept it a secret. Because, really, are you going to tell people? Like, how do you feel when I tell you there are rules? No one likes rules, right? And so I kept it a secret for a long time, and then I went on Ruby Rogues a couple of months later. And at the end of the podcast, like at 1 hour, the 1 hour 54 minute mark, at which time I thought, no, surely no one would still be listening, right? Because it went on and on and on. We were talking about code, and I told them the rules, and then it was like a bomb went off, but not for the reason you might think. The bomb. So again, I'm inside the bubble of my world, so I see all the tweets that my name is mentioned in. And there was a ton of talk about those rules. But what it turned out, oddly enough, was that I didn't hear from anybody who hated them. I heard from people who loved them. I heard over and over again from people that loved them. People made up posters and tweeted the posters to me. I mean, that's what I saw on my end. And I was struck not by whether or not the rules were a good idea, but how desperately we seemed to need rules. How much we wanted rules. That was very surprising to me. It's not about the rule itself, but about the value and meaning of having a rule at all. And so then I went away for a long time, and other people used the rules. They talked about them, they wrote blog posts about them, and I let that go on, and that was an interesting phenomenon. It was like a game of telephone, because I didn't really say the rules that I gave. Like, I gave the guys in San Fran some rules, and then I kind of said them wrong when I was on Rogues, and then people kind of heard them wrong. And so there was this sort of long chain of slightly different rules being made up. And people were applying whatever rules they had and finding those rules useful. And that was really interesting to me too. It didn't seem to matter what the rules were as much as that we had some. Yeah, and so I finally decided last fall I had to reclaim the rules. I had to say the term Sandi Metz rules in public. And I had to talk about what I meant, because the rules they had migrated to so many different variants of rules. And so tonight's talk is in 3 parts. I'm going to talk, I'm a recovering psychology student. I have a bachelor's degree in psychology, and so I have never gotten over my love of research. I believe in science. I believe in behavioral science. And so, of course, when I went to give a talk about rules, the first thing I did was went and read the research about rule following in humans. And so there's going to be a little social science in this, and that part, frankly, is more important than the tech part. But I'm going to iterate through what rules are, what social scientists think about rules. That'll take just a few minutes. And then we're going to segue into the technical part of the talk, and I'm going to tell you what my rules are and why I think they matter. And then we're going to circle back around to game theory and rule following in humans. All right? And the whole talk is about 30 minutes long, but this first 5 minutes didn't count. And so if you were going to set your watch, set it right now. All right, so there are three kinds of things that we think of as rules. The first one is taboos. All right, taboos are forbidden, things that are forbidden. They're cursed, unclean. There's often a threat of supernatural punishment. Incest and cannibalism are taboos, but oddly, frighteningly enough, there's no one single universal taboo. I know, just think about that for a minute. It's kind of a scary thought, isn't it? But so everything is okay somewhere. So taboos. And then next there's laws. That's the next level down. Laws are rules that govern behavior that are enforced by social institutions, which aren't, yeah, they're not always rational, but they are enforced by social institutions. So here's what we have, and look at that road. Like, do you want to be hiking on that road when they go by at 100 kilometers an hour? I don't know. So there's criminal and civil laws, right? These are social institutions. And then finally there's customs or norms. Norms are group-held beliefs about how members should behave in a given context. And they serve a lot of purposes, more than you'd think. There are many, many norms out there, and we use them to define group identity and to enforce social control. An example of a group norm is that thing that people in Europe do where they kiss each other on the cheek to greet. Right? This is the shift change at a police station in Paris. Now, I have been lucky enough to travel to Europe a little bit recently, and so I've been getting the Europeans to teach me European politeness. And so I know all the rules, right? You do this when you meet them the first time that day, and you do it again when you leave at the end of the day. They think hugging is way too intimate. Hugging is alarming. It's hard to get the Europeans to hug you. They want to do that A-frame hug thing, right? They don't want to touch anything if they hug you. And they don't, like, this feels incredibly intimate to me, right? But the French think of themselves as the polite people who greet by, it's called bisous, that kiss thing. And it depends on where you are, how many you do, and which direction you go. But there's a way you just pay attention to them. They all know that I'm bad at it, so they give me really strong physical cues about how many and which side, right? I mean, but they all get it, right? They're good at it. And so while this would, we have that sort of nervous giggle when we see this here in America. It feels frighteningly intimate. But they think of it as basic politeness. And they find us a little bit impolite that we don't do it, that we don't greet this way when we see them every day. If you have European friends here, ask them about European politeness. It's very interesting. And so it's it would be totally abnormal and inappropriate to do this in America, but it would be completely abnormal and inappropriate not to do it in France, in most of Europe and South America. And so taboos, laws, and norms are mostly unenforceable. They're generally unenforceable. And the question really isn't why people, it's not about violations, it's about why we follow them at all. In most cases, nobody is going to know and nothing is going to happen to you if you break one of these things. And so social scientists have a thing they call, of course, social rules system theory. They have an entire thing. There's an entire study of rules where they give answers to why we follow rules at all. And they give 8 reasons. I'm just going to whip through them. The first one is self-interest. You follow a rule to gain a benefit, to avoid a loss. There's a prize and you want it. And so you're going to follow the rules. So next, it's that whole part of marking yourself as part of a group. The French are that group, the polite people in Europe that greet each other by kissing, and we are the programmers that never leave trailing white space. Right? You know that. We define ourselves that way. There are all kinds of ways that groups identify themselves, and regardless of how informal or formal the rules are, they delineate our groups, and we use them to recognize one another. All you have to do is look at that picture and you know it's us. This is Brazil Conf. There's people in South America. You can tell. They're our folks. So next you might follow a rule because it was given to you by an authority. Religious authorities. This is the Pope in Barcelona. And there are secular authorities. There's no law that says you're out, but you go get in the dugout anyway, right? You're done. You know it. Groups promote authorities, and then they respect the rules that those authorities create. Fourth, people follow rules because they help maintain a sense of order. We love order. We follow rules that are otherwise meaningless because they make the world seem regular and dependable. We all know how far apart we're supposed to stand at the bus stop, and we hate it when people break that rule. The fifth reason is social sanctions. This is like, we'll put you in prison if you break the rule. That's the most obvious threat. But some rules have what they call inherent sanctions, which means the sanctions are built right into them, so we follow them. Even when they are not otherwise prohibited by law. And some rules we follow because of what they call the seventh reason, is the veil of ignorance. And so this means that you follow a rule even when you are harmed by doing so because you cannot understand, you can't see the consequence. There's a lot of different examples of this. If you have a rule that says, I'll take all free things, you could end up with a tattoo, right? And finally, there's habit. So we like to think that we're self-aware, that we understand our motivations, but there are many ways in which we are programmed by our experiences and our cultures, and the most deeply accepted rules are often the least questioned. So there you go. Taboos, laws, and norms, and here's why social scientists say we follow them. And would do so even often when it's against our self-interest. And so now I'm going to give you 5 rules. The rules I'm about to give you are norms. They're not laws, and they're certainly not taboos, even though sometimes we act like that. These are norms. And each of them is actually a constraint. It's a limitation on programming behavior. And here they go. First rule, a class can contain no more than 100 lines of code. A method may contain no more than 5 lines, and you may not pass more than 4 parameters into any method. And you can't just cheat with a hash. I have always regretted this 4. I sometimes think it ought to be 3. If there's 3, there's probably an object in there. If there's 4, there probably really is. 3 doesn't feel like quite enough, but 4 often feels like too many. And so these 3 rules, 100 lines in a class, 5 lines in a method, 4 parameters to a method, they're just about writing straight up Ruby code, object-oriented code. And these next 2 are about Rails code. A controller action may only initialize 1 instance variable to pass to its view. You can only set 1 instance variable in a controller action. And the controller action may know only about 2 class names. Now, when I said this on the rogues, I said 1. And what I meant was that you could know about a business class and a presenter class. Like you could say presenter.new on business.new on params. I said it wrong. This is one of those telephone game things, right? I said 1, but I meant 1 of each. And then some people took the 1 rule and ran with it, and it turns out that rule works just fine. Right? Tighter constraints don't seem to cause any problem here. And then I give them one final rule, which is that you can break any rule, that you can talk your pair into agreeing is a good idea. Right? And so now, these rules are not complicated. And in some ways, they're just dead simple. But they have enormous consequences. Imagine working on the app that was created by following these rules. The rules force you to create small objects. And they bias those small objects to be in poros, to be in plain old Ruby objects. Instead of being bound up, instead of having all this logic bound up in whatever framework you're using, the rules force you to create small objects of your own that know a minimal number of things. And so because of that, objects end up with few dependencies. We don't know what the future holds, but we want our apps to survive, and we'd like to reuse that code, and following these rules helps. The rules create changeable apps that are built of small objects that require little context and have few dependencies. And so you end up with simple, straightforward, well-tested code that can be reused in novel and unexpected ways. Now, the rules themselves aren't that special. And in some really basic ways, they are completely arbitrary. Right? Is 100 that much better than 99? Or that much worse than 101? It's not. There's a certain size monitor where a 100-line class will all fit on your screen. Right? That's what it is. They're just lines in the sand. And there are places that force you to look at your code and say, now is the time that I'm going to ask that question, should this be two objects? And what people tell me about it is that having the rules is comforting because they don't have to ask that question up until then. And then when they hit that boundary, they start thinking about what are the responsibilities and whether they should divide the object up. So the rules actually are completely meaningless. They're a means to an end. And that end, our goal, is to reduce the cost of writing software. We don't care about anything else. And if you define cost as time, money, or pain, we want to produce features at the lowest cost. And I assert that the best way to do this is to make small things. And I assert that the best way to do that is to define what small means, to make a rule about small and follow that rule. And so the rules exist to achieve a goal about code, and achieving that goal is more important than following the rules. I don't care. I'm the biggest rule breaker in here. I'm not bound to the rules. I'm bound to the thing that the rules give me. So I believe that I'm right. And I believe that if you do what I say, your code will get better. Right? I totally believe it. But it's not as if small things are free. There's always tension when we make this design choice. Choosing many small things over a few big things is a design choice. And there's tension between those two ends, and you're making trade-offs all the time. So following these rules places a bet that you're going to be happier later if you make a bunch of small things rather than if you make a few big ones. It's choosing between objects and procedures. And so imagine a continuum, right? And it's easier to think about this if you push it all the way out, push the continuum as far apart as possible. On one end, you have apps made of a few big procedures that contain lots of big classes, and those classes have a few big methods in them. On the other end of the continuum, you have a bunch of tiny objects, maybe with just a few methods in them, and those methods are just a few lines long. A procedure is a big step-by-step list of things, and so it's really easy to look at a procedure and understand what it does. When an app is made up of a few big procedures, you can look at the source code on disk and know what the app is supposed to do. And that can be very, very comforting. On the other end of the continuum, if you have a bunch of small objects, the information contained in the source code files on disk is not enough to let you know how the app behaves. And it's because there's something missing. When you have a procedure where thing 2 follows thing 1 and thing 3 follows thing 2, you understand the order of events because they're on the stack, right? You're walking down the stack. When you have a bunch of small objects and you wire them together somehow so that they have an interaction, that interaction does not exist until you reconstitute them into objects in memory and send messages between them. When you look at the source code on disk of many small objects, you cannot see those messages. And you have to reconstruct the running app in your mind, in your own head, from how it looks on disk. And very often you can't do that. And this is why people find looking at many small objects harder to initially understand than looking at a few big procedures, because it's not all there. Now, the problem with big procedures is that they're hard to reuse, and if you have to change something about them, you have to go in and touch code that's related to a whole bunch of other code. It's easy to break stuff, right? So procedures are easy to understand initially, but difficult to change and reuse. Smaller objects there's more cognitive load on you to understand how an application made of small objects works to begin with, but it's very easy to reuse. It's easy to understand a single part, even though the whole is harder to understand, and it's easy to reuse a single piece. And so those messages, the things that are changeable, the things that are not encoded in the small objects on disk, they create seams. And when I have objects that I can plug into different arrangements and have the messages go back and forth between them in a new way, it gives me a kind of substitutability, reusability. The messages almost act like walls that hide the objects. The messages act like walls that define roles. They define interfaces that the objects hide behind. And so there's a lot of changeability I get when I make small things that I don't have when I have big objects, but that is not visible when you look at the source code on disk. Changeability is based on message passing. And so if you want changeability, you have to create seams by sending messages. So you have to break objects up into smaller parts. And so there's a tension. I completely stipulate to the fact that there is a cost. It's not like one is always better than another. It's context dependent. But my assertion to you is that mostly you're better off with small things than you are with a few big things. But as I started putting this talk together in the fall for a conference in September, I really wanted to do some slightly empirical testing of whether that was just my opinion or whether the people who were not me, who were trying to follow these rules, thought that the same was true, that whether their experience was that it worked out well. And so I'm going to tell you two stories about that. One is that, actually, the first story is about, I was at RailsConf. I was here last year at RailsConf. I was actually here at a party last year. And Ward Cunningham, bless his heart, took me and named all the bridges outside the windows. It was very cool. So at RailsConf, somebody who had read the book, Practical Object-Oriented Design in Ruby, and he kind of drank the Kool-Aid, right? So he's trying to make small things instead of big things. But he didn't really know much, right? He was teaching himself like many of us have. And he came to me with a question, and it's that thing, where you're not where you used to be, you learn a bunch of stuff, and you forget you can't even imagine, I couldn't even figure out what question he was asking me. And so we spent a while in the hall over at the Portland Civic Center with me trying to, what, and finally I understood his question to be this. He was saying, okay, I'm trying to do it. I'm trying to write Rails apps made of a whole bunch of small objects. I'm really, really trying. But I want you to tell me when I'll understand my new app in the same way that I understood my old. Right? When will I understood an app made of a lot of small objects? In the same way that I understood an app made of a few big procedures. And when I finally understood that to be his question, I had to look at him and say, never. Never. You never will. It's not as if these are two arcing paths that lead to the same destination. The app that you get is different, and the way you think about it is different. It isn't that they're just separate ways to reach the same endpoint. I said, you will never understand this app in the same way that you understand your old one. What will happen instead is that you will cease to care. That's the change that you're waiting on, all right? And in order to illustrate why, I'll tell you a second story. So the guys at Thoughtbot, after the rules came out, a young man named Caleb decided that they were going to do a science experiment, and they were going to adopt the rules for a new greenfield project. And so they had 5 or 6 people working on an app for a couple of months, and they used the rules the whole time. And so about the time when I'm working on this talk, I was having some conversations with him, and they were gracious enough to get into a hangout with me and let me ask them questions about their experience. And here's what they told me. They said, after the end of the experiment, no one was willing to give up the rules. Right? They had a greenfield app that was written that had no classes bigger than this, no methods bigger than this, like all the code looked like this, and they were unwilling to deviate from those rules. And that as people cycled off this project and onto other projects, they were like they would take the rules with them and make people writing code on those other projects start following these rules. And so they liked the rules, and they felt like the rules gave them better code. But I was particularly concerned about this thing about the cognitive load of having many small objects, and about whether less experienced programmers would find it hard to work on apps that were made of many small things. And so I asked them particularly about that. How did the junior people do? And there was some junior guy in there, I forget his name, Mark, Dave, Jim, Dan. They just put the camera on this poor guy. They put him right on the spot. And I said, you know, so he had worked on other apps that were made of many big procedures, and then he'd worked on this app that they'd built based on these rules. And I said, how was it? And he said that he loved it. And when I asked him why, he said it was because he knew that he didn't have to understand everything, that all he had to understand was the place where he was trying to make a change, and that if he could keep the tests running green, he could not break some distant thing. When he was dealing with the projects that had big procedures, he was always breaking stuff because he didn't know. He wasn't, you know, he didn't have enough experience to look around and predict what distant and apparently unrelated side effect his change was going to create. And so he would break things all the time. Okay? Now it was a myth, so this myth that he gets it all, like it wasn't like you know, when he started working on an app that had many small objects, we got to take that myth off the table, right? He didn't understand it all, but it was okay because he didn't need to. And he understood that he didn't need to. And so he really loved it. I was actually quite surprised. I thought he would say, oh, I was disoriented all the time, like I was unmoored in space. I didn't know what I was doing. But what he said was, oh, I love this app because I feel safe all the time. He used those exact words, I feel safe. And so, blah, 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 blah. Okay. And so, there's a lot of slides here that say stuff. Oh, Paul was his name, that young boy, Paul, in case he watches this. Thank you, Paul. And so that's the power of small objects. And writing them, choosing to write small objects requires a change in perspective. I suspect many of you have lots of large objects, and it's hard to imagine doing this. Most of us, if you're a Rails programmer, you probably think of your apps as Rails apps. Rails has an opinion about how to write code, and that opinion is tremendously helpful. I am grateful to Rails, right? It brought a lot of people to the web. It brought a lot of self-trained folks who came from the kind of background that I have into well-paying jobs. It's tremendously helpful, that opinion that Rails has. And some of you here probably have been around long enough to remember that blog post in 10-minute thing that, right? Who raise your hand if you saw that? Yeah, so a lot of you, right? So if you think back on that, or even what you get if you do scaffolding, if you scaffold the blog app right now, think about how that looks. What you get is a controller action that knows the name of one class, right? Post. And you get a controller action that sets one instance variable at post. Like, this is the Rails pattern. It's not that I'm trying to get you to break the Rails pattern. I'm trying to get you to follow it, right? But what happens is that classic Rails app, that simple app, is a wrapper that does CRUD operations around a database, right? Create, replace, update, delete. Right? And so if what you need on the web is a wrapper around a database, the Rails scaffolding code is perfect. It does exactly what you need. However, many of you are probably not working on Rails apps. You're working on apps that use Rails. And the distinction I would make here is that you have business logic that does not map directly to a row in a database table. And when you get there, when you have to deal with having business logic that doesn't map to a single row in a database table, or controller actions that don't map to a row in a database table, all of a sudden, in order to follow the Rails pattern, you have to create new objects. You have to drive the edges of their framework apart and create your own new objects that fit in the middle. You have to put some new PO-row in between. You can't just have subclasses of action, controller, whatever that is, and subclasses of active record base. You got to make new stuff and put it in the middle, or else your controllers end up knowing the names of a bunch of active record models, right, and doing the interaction between them. And so, what did I hate it when I do that, and I just do it. Let's just do this. Look, aren't we right back where we were? Yes. And so the 5 rules force you to do it. My rules force that to happen. If you make small things, you're going to end up having to make PO-rows, and you have to put them in the space between things. And then you'll have if you have an application that uses Rails, your business logic will get unwound from the framework. So I think you should follow the rules because it's, first of all, in your self-interest. I think it's totally in your self-interest to follow these rules. But it turns out, okay, and now we're going to get to the third part, the game theory part of this talk. It turns out there's more to rule following. And I didn't know this till I started prepping this talk. There's some really, at least to me, interesting new research by these guys, Kimbrough and Vostruk-Dutnov. And here's the name. Okay, it's an academic study, so it looks like that, which, I don't know. Here, I'll help you. Right? So they have this theory that rules are a way that we screen for cooperative types. And here's the study. It's in 2 parts. They took all the subjects and they divided them into groups of 8. So we're going to deal with 8 people. And they had each single person in the group of 8 play a game. And this game, the purpose of this game is to decide among those 8 people who were more rule following and who were more rule breaking. And here's how the game works. You have this little person. They're supposed to walk across these stoplights. Their task is to walk from left to right. So pushing the walk button moves them to the next light, and the figure automatically stops at all the red lights. Now they did this in Europe. So you get €8. They give you €8 to start with, and you lose money for every second it takes you to get that little person over to the other side. 8 cents a second as you walk. Now, the red lights last 5 seconds, and this is what the subjects are told. This was the instruction they get. The rule is to wait at each stoplight until it turns green. This is what they told them. And so it takes 4 seconds to walk from light to light and from light to the end, and the lights are 5 seconds long, so you're going to lose €2 walking and €2 more if you wait at every light. So if you get 8 to begin with, if you follow all the rules, the most you get to keep is 4. And so here's how some people play the game. They wait, they go to the first light, they wait. Light turns green, they press walk. The little person walks over there, they wait right here. They wait, the light turns green, they press walk again. Okay, that's how they play it. All right. Now I can see you laughing because I know you think you know what you do. All right. So that's some people play the game like that. Other people play the game like this. Because it turns out the walk button works even if the light's red. Now, okay, it's funny, and I know. And all of you, it's like you're programmers and you're gamers. So you're thinking, well, I'm a rule breaker, right? You're feeling all rule breaky. All right, you are. But so let me give you a different, I think the instructions are context dependent. So what if I told you, make this change in this code, and then remove the trailing white space, and then press the walk button? Could you bear it? Could you leave trailing white space in there just to earn €2? You wouldn't. And it's such a self-selecting thing. Like people who come to talks, like you're the most trailing white space removers. Like you have self-selected to be in this group. And so I contend that even though by these criteria, maybe you are a rule breaker, but in real life for things that matter, you are all rule followers. All right, and so they took the 8 people, they gave them all that, and they took the group of 8 and they divided them up into the 4 most rule following and the 4 most rule breaking. And there's a real difference. The average wait time was 30 seconds for the rule following group. Average wait time was 30 seconds average for rule followers. So 15 seconds for rule breakers and 30 seconds for rule followers. And so it isn't like they were just a little bit different. They were way different. Like some people waited a lot and some people hardly waited at all. And so now I have 2 groups of 4, the rule following group and the rule breaking group, and they had them play a new game. And that game is a game where winning requires cooperation. It involves, they call these common pool resource games. Right? So the game involves sharing a common resource, and here's how the game works. I'm just going to run through this quickly. It'll be obvious. So 4 players, they play 10 rounds. During each round, they draw tokens. And so every player has an infinite pool of their own tokens, private tokens. These tokens are all worth 1. And there's a shared pool of tokens. It's capped at 360, and these tokens are all better. They're worth 2. And so over 10 rounds, each of the 4 players draws 60 tokens every round. And so it could go like this, all right? Given that public token, so I'm going to draw, there's 4 of us, there's 360 in the common pool. Every player gets to draw 60 tokens in every round. In the first round, probably what happens is that everybody just takes 60 out of the common pool. They're worth more, why not? Now, and that leaves 120 tokens. Now, there's a few things I haven't told you. 2 more rules. One is that the public pool regenerates between rounds by half, as long as it isn't below 30. All right, so that's the first one. You have to, if you get below 30, it quits regenerating. The other is that in any round where the 4 players choose enough tokens out of the common pool to get it below 0, they get tokens in proportion to their choice. All right, and so you can think of the shared pool as standing proxy for a shared commons, right? A place where, a field where people graze, lots of different people graze cattle, a fishery, right, off the coast here where lots of different people fish, or perhaps a long-lived application on which many programmers work. And you can overgraze a field or overfish a sea or screw around with the code in an app for a while, and you still get good out of it. But a point comes, if you abuse the resource too much for too long, a point comes where there's nothing left of value in it. And so if you're playing a game where the health of your application over many rounds matters, and you trust your fellow players, after choosing 60 tokens in the first round, here's how you play round 2. So you do this math. This is the equation, right? I got 180. Well, I can't get into the bottom 30, or else it'll quit regenerating, and it's always important. Like we will, over 10 rounds, the cumulative score of the whole group will be higher if we keep the shared pool alive. I can benefit at your expense by taking them all, but we as a group will do better if we keep the pool alive. And so I divide by 4, and that's 37.5, and now I got to round down. Now in the experiment, they did not allow them to talk to one another. And so you couldn't negotiate, you take 38 and I'll take 37, right? You couldn't do that. You just have to round down if you want to keep the pool alive. And so then everybody, if you want to cooperate and keep the pool alive, you end up saying 37. And in the next round, I got 180, and then I clicked, I really did, oh, there we go. Everybody takes 37. I end up with some number like 32. And that's enough to regenerate, so we multiply that by 0.5, and then we get 48. And so everybody's going to do best over the long term if we keep it alive, but you can see it, using this formula, it decreases very rapidly, right? There's just a few left for the people, but there's a clear formula here, right? The number I have now, minus 30 divided by 4. If every player chooses this many tokens in each round, so the pool will last forever. And so in the next round, you only get 4 if you play it this way. Now, it turns out there's mathematically ways to do better. Like if everybody takes fewer in every round, you could do better, but seriously, like who's going to do that on the fly? Again, individuals are going to do better if you just say, screw them, I'm going to take the whole rest of the pool. Like I could get more points than all of you if I just take it in one round, but we'll do better as a group if we keep the pool alive. And so they played that first game to identify rule followers and rule breakers. They divided the group of 8 into 2 groups, one group of followers and one group of breakers, and then they had them play this cooperative game. And here's what happened. The rule following groups are 4 times more likely than the rule breaking groups to keep the pool alive. 4 times. And not only that, they fail in many cases, but they did mathematical analysis about their choices, and you can tell from the choices they're making that they're trying to keep the pool alive. They just cannot do the math under pressure. Right? And the researchers they didn't let them talk, like I said before. The researchers hypothesized that had they allowed them to talk, they would have maintained the pool indefinitely. It was clear that they meant to do it. The following groups, the followers, so they cooperate for mutual gain. The rule breaking groups consume the resources much more quickly, and you can tell from their choices they're not even trying. It's as if during each round their calculation looks like this. All right? And so the study also measured, they did a whole bunch of stats, right? The study also measured something that, I'm sorry, I have a hard time saying this, reciprocity. Reciprocity, okay? So reciprocity is the tendency of someone to do in the next round what someone else did in the prior, right? Tit for tat. It's that kind of thing. And so it turns out that the choices we make are highly reciprocal. You may notice this at work. The choices are highly reciprocal. If everyone is nice, so when the followers are together, they're all nice. It's like having 3 variants of Matts on your team, right? When you're on a team full of Mattses, everyone is nice, and so the system tends to make the pool be preserved. However, players reciprocate bad behavior too. And when a bunch of rule breakers get together, they all behave badly, and then they reciprocate bad behavior, and we have this race to the bottom. The frightening thing about this research is what happens when you do mixed groups. So they ran the study again after they had figured out that the follower groups were a lot more likely to keep the pool alive than the breaking groups. And they arranged groups this way. They would put 1 rule breaker in a group of 3 rule followers. And these groups behave like breaker groups. And the authors of the study suggest that this is because of that quality of reciprocity. It's as if a round is played where someone does that, and it pokes everyone right in the eye, right? And that fairness gene, that monkey grape thing, in case you've seen that video. And so in the next round, everybody does this. Yeah, buddy. We got you. And I'm going to quote some from the study, okay? They say, this will always be true. Having 1 rule breaker on a team will inevitably cause it to exhaust the shared pool. And by extension, if we can use my analogy, to overgraze a field, or overfish the sea, or screw up the app. Now, I'm a little bit uncomfortable drawing the analogy all the way to software here, but what they say, I'm uncomfortable, but it's just because I fear being criticized, frankly, because I've seen many teams that have this exact problem. 1 rule breaker can destroy the team. The authors of the study also say that the only way to avoid the inevitability of mixed groups exhausting the resource is to screen for rule breakers and preemptively exclude them. Sarah May, whom some of you may know, I gave this talk in somewhere recently, and she was there, and she suggested that having that 1-week pairing interview was a preemptive screening for rule-following types. I mean, I don't know. I don't know how to do it in a way that seems fair and ethical, but what I do know is that we all know this problem, and that talking about it in terms of game theory has given me a way to think about cooperative teams and to thinking about the apps as shared pool resources, and having this research to think about, should we preemptively exclude? Maybe we should try harder. The problem of mixed groups not doing very well is a real one, and we see it all the time. And so I have a friend that says bad programming drives out good, right? The pithy version of this, right? Because very often the programmer that we would think of as bad, they consume the resource, right? They make messes out of our clean code, and then we clean up their code, and then they make messes out of code, and the bosses love them and hate us, right? People who do not know tech think they're fast and we're slow. And I don't quite know how to, I don't really know how to deal with it. I don't have a solution for this as much as I think we should find a language to talk about this problem and be clear amongst ourselves that it is a problem and that we should find a way to deal with it. And so in light of the study, what are the consequences of following rules? Where all the technical things I told you are still true. My rules bias you toward creating small objects and towards POROs and away from dependencies. But it turns out those are not the most important things. That following a rule, following any agreed upon set of rules, being willing to make rules and follow them sends a signal that you are willing to cooperate with others. that you're willing to do what it takes to maintain an application over time and round after round after round, no matter what the future holds. And so they say, Kimbrough and whatever that guy's name is, rules screen for cooperative types. And those are just the types with whom we want to work. We can add one more thing to this list of why we follow rules. It's because we want to signal that we're cooperators. And so they matter. They matter technically and they matter socially. From a technical standpoint, they let you write better software. But from a social standpoint, they let you find trustworthy humans. There you go. Go find some rules.